Hello everyone, welcome to Rankingpedia education platform. In this video, we are going to discuss important numerical questions that can be asked in your TPSC Junior Engineer Civil Mains examination. So watch till the end. If you haven't installed our application Rankingpedia Education, then please install our application, and in our application when you will visit free quiz section, you can attend free quizzes, as well as your syllabus is already uploaded in syllabus section. You can also access previous year question paper in previous year paper section. If you are preparing for TPSC Junior Engineer Civil exam, you can enroll in this course. In this course, you will get practice paper, which is very important for your mains examination. Course fee is just 1499. What you will get in this complete batch course, which is specially designed for your prelims plus mains examination. So in this, you will get ebook that covers your entire civil engineering portion, question bank that covers your entire civil engineering portion, mock test series in which 10 quality mock tests you will get, and also test pass feature is also enabled in your course Tripura TPSC Junior Engineer Civil course. Course medium is complete English. So your first question is: a concrete of M60 grade obtains a cube strength of 80 MPa if the cube strength is to be considered as the characteristic strength, then the modulus of elasticity shall be approximately equal to. So we have to calculate the modulus of elasticity. So what is given? First we will note down the given quantity. So given is your concrete grade is given, which is concrete grade is given, which is M60, and cube strength is given, which is here mentioned 80 MPa. Cube strength is 80 MPa. So if the cube strength is to be considered as the characteristic strength, then what will happen? Then your pk is equals to 80 MPa. Now what we have to calculate? We have to find out the value of modulus of elasticity. So we have to calculate modulus of elasticity, which is EC is equals to 5000 under root F, here 5000 whole under root, pk value is 80 MPa, which is P. So 5000 root 80. So we have to find out this value 5000, and root 80 value you can use calculator right now. So it is approximately 8.94 something, and after calculating this, so you will get the final value, which is approximate 44,721.35, which is approximately, you can say it is around something 45,000. The modulus of elasticity value is around 45,000. Now you can check the option. So option number B is correct, 45,000. As it is mentioned, answer to the nearest 1000 value. So nearest 1000 value is 45,000. So option number B is correct. Next question is: a short axially loaded square column 500 mm into 500 mm is subjected to service load of 2000 kN. Calculate the ultimate load and minimum area of longitudinal reinforcement as per IS 456 to 2000. So given quantity, first we will note down. So what is given? P 500 mm. Next is your D, which is 500 mm. P is given is your 2000 kN. We have to calculate ultimate load. So for ultimate load, which is denoted by PU, is 1.5 to, from here PU is equals to 1.5 and value is 2000 kN. After solving this, you will get 3000 kN. So ultimate load value is 3000 kN. Next, what we have to calculate? We have to calculate minimum area of longitudinal reinforcement. So minimum area of longitudinal reinforcement is 0.8% of BD, and BD value is already given in the question. 0.8% of BD. B is 500 mm, A is 500 mm. After calculating this, what value you will get? You will get 2000 mm. So minimum area of longitudinal reinforcement is 2000 mm, and your ultimate load value is, which is 3000 kN. So which of the following option is correct? Option number E is correct. Next question is, water is flowing through a pipe of 6 centimeter diameter. Diameter is given under a pressure of, so pressure is given 200 into 10 days to the power 3 Newton per meter square, and with a mean velocity of 2 meter per second. Find the total head or total energy per unit weight of the water at a cross section which is 6 meter above the datum line. So first we will what do? First we will note down the given value. So given data, first we will note down given data. So here given data is diameter of pipe is given. So diameter of pipe which is 6 centimeter. Next, what is given? Pressure is given. Pressure is given which is 200 into 10 days to the power 3 Newton per meter square. Next, mean velocity is given. Velocity is given which is 2 meter per second, and also datum line is given which is 6 meter above. So Bernoulli's equation is what? Bernoulli's equation. So you have to remember some equation. Rho g plus v square by 2g plus z. Now we will just put the value. P is 200 in 10 days to the power 3 upon rho g. Rho is 1000 into g, can take 9.81 plus v square. Velocity is which is square by 2 into 9.1 plus z is what? Z is given which is 4. So datum line is here mentioned which is 6. Now we have to calculate this. So from here, after calculating, what value you will get? Will be cancelled out. So 200 by 9.1 plus 2 by 9.1 plus 6. After calculating, you will get a value approx 26.59 meter. So this is total head. Total head value is 26.59 meter, and we have to calculate this total head or total energy per unit. So total head value is 26.59, and which option is correct? Option number D is correct, 26.5. Next question is 2 liters of oil weight 16 N. Calculate the specific gravity of oil. So what we have to calculate? We have to calculate specific gravity of oil. Take density of water. So density of water is given 998 kilogram per meter cube. So first what we will do, we will note down the given data. So given data is W is given which is weight in Newton. Then 2 liters volume is also given, 2 liters over here, 2 liters of an oil weight. Volume is given 2 liter. If we will convert in meter cube, so 2 into 10 days to the power minus 3 meter cube. Next, what is given? Specific gravity we have to calculate. Density of water is given. So density of water, we will note down the value 998 kilogram per meter cube. What we have to calculate? We have to calculate the specific gravity of oil. This thing we have to calculate. So what we know? We know that W is equals to E. Now from W value is given 16 M. You have to find out K is 9.81. You can assume over here P value you can take 9.81 meter per second square. This you can take. So from here we will get the value of M, which is 16. So after calculating, you can use calculator. So you will get 1.6309 kg. So this is the value of mass from V is equals to N. And now what we have to find out? We have to find out the specific gravity of oil. So for this, first we need to know the density of oil. Density of oil, which is denoted by this, is equals to M by V. M is 1.639 kg. But this thing we have calculated, and V is 2 into 10 raised to the power minus. Density of oil will be, so after calculating, density of oil will be 815.49 kg per meter cube, because P is meter cube, this, and here the value is in kg. So this will be, so density of oil will be 815.49 kilogram per meter cube. So we have calculated density of oil. Now for specific gravity of oil, calculate specific gravity of oil. So for this, E is equals to density of oil by density of water. Density of oil is 815.49 kilogram per meter cube by density of water. So density of water is mentioned, which is 990 kilogram per meter cube, and value will be cancelled out. So G, after calculating 815.49 divided by 998, you will get value approximate 0.817. So this is the final value of specific gravity of oil. So which is the final answer? So here you can take this option, option number C, which is approximate 0.816. So option number C is correct, 0.81. Next question is, a plate at a distance of 0.03 mm from a fixed plate moves at 0.8 meter per second and requires a force of 1.5 Newton per meter square area of plate. So what we have to determine? So we have to find out the dynamic viscosity of liquid between the plates. So first what we will do, we will note down the given quantity. So distance between moving plate and fixed plate, which is given, is 0.03 mm. So dy is given 0.03 mm, and in meter it will be 0.03 into 10 raised to the power minus 3 meter. Next, what is given? Velocity of moving plate is given. Velocity of moving plate, which is denoted by du, is 0.8 meter per second is given. Next, shear force is given. So shear stress is given. Shear stress is given, which is 1.50 Newton per meter square. Shear stress is given. What we have to calculate? We have to calculate dynamic viscosity of liquid. So we have to calculate dynamic viscosity, which we will be denoting by so shear stress is equals to dynamic viscosity dV by dy. Tau value is 1.5 0 Newton per meter square, 0.meter per second by dy is 0.03 10 raised to the power minus 1.50 Newton per meter square. Here mu is equals to, after calculating, so here 0 into 0.5 0.03 10 raised to the power b over here mu is equals to 0.0525 10 raised to the power minus 3 Newton second per meter square. You can use calculator. So after calculating this through calculator, your mu value is 56.25 10 raised to the power minus 6 Newton second per meter square, which is the final answer. Which option is correct? So option number A is correct. 56.25 10 raised to the power minus 6 Newton second per meter square. So this is the final value of dynamic viscosity of liquid between the plates. So what we have actually done in this question, first we have noted down the given quantity. Given quantity are here, like your distance between moving plate and a fixed plate is given, which is dy. Dy is 0.03 mm. Then we have converted in meter. 0.03 into 10 raised to the power minus 3 is converted in meter. Next is your velocity of moving plate is given, which is du is given 0.8 meter per second. Next is your shear stress is given here, which is denoted by tau, 1.50 Newton per meter square. And we have to find out dynamic viscosity. So for dynamic viscosity, shear stress is equals to dynamic viscosity, then du by dy. From here, we can easily find out dynamic viscosity. So option number A is correct. A hydraulic press has a ram of cross-section area is mentioned 30 into 30 centimeter, and a plunger of cross-section area, which is also mentioned 4 into 4 centimeter as shown in the figure. So what we have to find? We have to find the force, which is F, required to lift the weight. Weight is given, W is given, it is 30 kilonewton. Okay, 30 kN is given, so we will note down what is given. So over here, what is given? First is your cross-section area is given, which is 30 to 30 centimeter, and plunger of cross-section area is 4 into 4 centimeter. Area is given, this is your area, it is 900 centimeter square, and plunger cross section area is 4 into 4 centimeter square, which is 16 centimeter. So what we have to find? We have to find the force. What we have to find? We have to find the force. And given quantity, weight is also given, is denoted by W, which is 30. So as we know, work force by, and W is given, which is 30 kilo. Then lift of weight is given 30 kilonewton. Okay, which over here we have third. So W by A, which is weight of lift by A, that is your cross section area, which is 30 by 900 centimeter square into F. Another force which is given. So another force we have to calculate. F. A is this one, cross section area of plunger, which is centimeter square. So when we calculate 30 by 900 is equals to 30 by 900. 3 F is equal to 60 by 3, which will be force come around something 533.3 Newton around. This is the final answer. Force is 533.3. Option number B is correct. Next question is a timber test specimen of size is mentioned 50 into 50 millimeter in cross section and a 150 in length was tested for its specific gravity if the specimen weight 250 gram and has 15% of moisture content. What we have to calculate? Calculate its specific gravity by counting the moisture content. So we will note down first given things. So first, the given thing is volume is given. Volume of a specimen is mentioned. Yes, 50 into 50 to 150 is mentioned over here in both. Volume is, when we will multiply this, so it will be around millimeter cube. Volume is always in millimeter cube, or here it is in cube. You have to remember this. When we will convert this in centimeter cube, so that will be 375 centimeter cube. Next, which quantity is given? Is your percentage. Moisture content is given. Percentage of moisture content. Moisture content is given. Which is 15. Next is what is given? Weight is given. Weight of specimen is given. Just 3 gram. And we have to calculate specific gravity. For specific gravity, this is the formula: 100 by plus m. Now here, what is given? Weight of specimen 50 by volume of specimen is 375. 100 by 100 plus moisture content. Percentage of moisture content is given, which we have to calculate this only. 250 by 35 into 100 by 150. We have to calculate this. You can use calculator right now. After using calculator, I have got the value. Specific gravity is around 0.579. Final answer is option number D is correct. 0.579 is the right answer. Specific gravity is 0.579. Next question is, in a circular tube of diameter is given 100 and a length 15 meter is given with a laminar flow, the Darcy friction factor is estimated to be 0.05. We have to calculate Reynolds number. So what is given? We'll first note down that quantity. Given is diameter of tube is given. Diameter of tube is equals to 100 is given. 100 when we will convert 100 into meter, it will be 0.1 meter. Then next quantity is length is given. Length of tube, let's say denoted by small l, is here mentioned 15 15 meter is the length of tube. Next is given your Darcy friction factor. Darcy friction factor is given, which is denoted by small f, and it is 0.05. and we have to calculate what we have to calculate? We have to calculate the Reynolds number. So as we know, friction factor is what? Friction factor left is 65. What's number? So from here, Reynolds number is pi f, which is friction factor. Reynolds number is 4. Friction factor is 0.05. After calculating 64 by 0.05, or you can say 100, is Re is equals to, when you will calculate this, it will be 1280, which is the final answer. 1280 is the value of Reynolds number. Option number D is correct. 12. Next question is, calculate the slenderness ratio and classify type in accordance with IS 456,000 if the diameter of column is given 300 m and effective length is given 3 meter. So first we will note down the things. Given data is, diameter of column is given. Diameter of column given, which is 300 mm. Next is your effective length is given. Effective length of column is given, which is 3 meter. When 3 meter will be converted into mm, then 3000 mm. Slenderness ratio we have to calculate. Okay, as question says, calculate slenderness ratio and classify the column type. Okay, so we have to classify accordingly column type. First we need to find out slenderness ratio. So slenderness ratio is equals to by D, which is length is given, effective length of column is 3000 millimeter, by D is given, diameter of column is 300 millimeter. So it will be 10. Slenderness ratio is 10. Now if slenderness ratio is less than 12, then column will be short, and here the value is 10. So yes, it is obviously less than 12, so we can say column is short. Which of the following option is correct? Option number D is correct, 10, and classify the column type, which is a short column. Okay. Next question is, the shear stress at a point in a liquid is found to be 0.02 n per meter square. The velocity gradient at this point is 0.20. What will be the viscosity of liquid in poise? We have to calculate viscosity of liquid. So first we will note down the given data. What is given? Shear stress is given. Shear stress denoted by this 0.02 per meter square, and we have to calculate velocity gradient is also given. Velocity gradient is pi, which is 0.20, and we have to calculate viscosity of liquid. This thing we have to calculate. Formula for this is shear stress, which is denoted by this, by velocity gradients. Velocity gradients is du by viscosity of liquid 0.02 by 0.20. After calculating, what value we have got? 0.1 second per meter square. And when we will convert 0.1 Newton per meter square, it is 1 poise. So yes, we can say viscosity of liquid in poise is 1. Which of the following option is correct? Option number D is correct. viscosity of liquid in poise is 1. Next question is, as per IS 2770 part 1, the load at failure in a pull-out test was found to be 180 kN. We have to calculate bond strength if the bar diameter is 20 mm and its embedded length into concrete is 300 mm. What is given? We will note down first. Given is load is given which is 180 kN. Load is given, then diameter is given. Diameter is 20. Next thing, embedded length is given. Embedded length, which we will be denoting by small l. It is given 300 mm. What we have to calculate? We have to calculate the bond strength. We have to calculate bond strength. Bond strength, which is load by pi into diameter embedded length. Load is given 180 kilonewton. So in Newton it will be power 3 whole upon pi into, here you can see value is given in pi, so we will not put the value of pi. Otherwise, if in question value is given, you can put value of pi. Here d, which is diameter, is given, that is your 20 mm, and next length is given 300 mm to 300. So after calculating, what we will get? Or 3 cancel out this, 30 cancel, then 180 by pi. Here we will get 30 by pi. It is in Newton per. This is the final. Option number A is correct. 30 by pi per, because diameter and embedded length, these two quantities are mentioned in millimeter, and in option we have quantity in mil. We have not converted in. Next question is, a rectangular RCC beam section having a width is given, width of 200 millimeter and a depth of 300 millimeter is subjected to factored shear force of 3 kilonewton. So what we have to determine? We have to determine the nominal shear stress acting in the section if effective cover is 50 mm and grade of concrete is M20 and the grade of steel is Fe415. We have to calculate the nominal shear stress. This thing we have to calculate. So first we will note down the given quantity. So first we will note down the given quantity. Over here, what is given? Width is given. Width of beam is given. Width of beam given 200 mm. Then total depth is given. Total depth is given, which we can denote by capital D, and it is 300 mm. Width we will be denoting this by small b, and total depth we will denoting by capital D. Now next thing, what is given? Effective cover is given. Effective cover is given, and this we will denote by P dash. This 50. Next, what is given? Next is your factored shear force is given. Factored shear force. Factored shear force is given, which is, and it is Kn is your kilonewton. Effective depth, calculate first. Effective depth E, how we will be calculating this? Total depth minus minus what? Total depth minus effective cover. Effective cover, which is capital D minus D dash, and capital D is mentioned, which is 300 millimeter minus 50 millimeter. Effective depth D, what will be getting? 2 mm. So effective depth we have calculated, which is 50 mm. Now we have to calculate what? Determine the nominal shear stress. Nominal shear stress. Shear stress is what? Factored shear stress, factored shear force by CD. D is what? D is your width of beam. D is what? D is your effective depth, which we have calculated to 50 mm. So nominal shear stress, factored force, factored shear force is 6 kilonewton. So in 10 raised to the power, B is given. B is width of beam is mentioned, which is 200 millimeter into D. D is your effective depth. Effective depth is 50 meter. And when we calculate this, cancel out what we have, 660 by 50. Ratio is 6 by 5. And when we will calculate this, what will we get the final answer? 1.2 Newton per millimeter. This is the final answer. Option number D is correct. Next question is, a centrifugal pump driven by directly coupled 2 kW motor of speed is mentioned 1400 rpm is proposed to be connected to a motor of speed 2800 rpm. The power of motor should be. So we have to calculate the power of given quantity is speed of motor is mentioned. Speed of motor, and this we will be denoting by 1 is mentioned 1400 rpm. Next is N2 is mentioned. N2 is also mentioned, which is 2800 rpm. Coupled is mentioned. Coupled, let's say P1 is 2 kW. What we have to calculate? We have to calculate power of centrifugal pump. Power of centrifugal pump. Centrifugal pump, which is P is equals to K N cube. Then ratio is P1 by P2 is equals to N1 whole cube by N2 whole cube, or you can say N1 by N2 whole cube. So from this ratio we will calculate power. P1 by P2 is equals to N1 cube by N2 cube, and here P2 is equal to N1 cube N2 P1 by 1 cube. Value we will be putting to N2 cube. What is N2? 2800 into whole cube into P1 is, P1 mentioned is 2 kW. 2 whole upon N1 cube. N1 cube is 1400 into whole cube. So P2 is twice of, so here P2 is 2 whole cube, P2 is 16 kW, which is the final answer. Option number D is correct. Okay. Next question is, a capillary tube of a diameter is mentioned 4 mm is dipped into liquid of specific gravity. Specific gravity is mentioned 0.6. Next, the liquid rise in the tube by 20 mm, making an angle of contact. Now, angle of contact is mentioned, which is 0 degree with the tube. We have to determine what? Determine the surface tension of the liquid in contact with air and the glass. We have to determine the surface. First thing, what we will doing? We will note down the given data. The given data is diameter is mentioned. Diameter is mentioned, which is 4 mm. So we will calculate radius of tube. Let's say small r is diameter of tube by 2. Okay, then 4 by 2, radius of tube is 2 mm, or if it is converted in meter, then it will be 2 into 10 raised to the power minus 3 here. So this is your small r value. Next is what is given? Density is given. Density of liquid denoted by rho is given 0.6 into 10 raised to the power 3 or 1000 kg per meter cube. Next is given. Next is your liquid rise is given. Liquid rise in tube is given, which is liquid rise in tube, which is small h is given 20 mm, and when we will convert 20 mm in meter, then it into 10 raised to the power minus 3. Angle of contact is also given. Angle of contact is given, which is denoted by theta, and it is 0 degree. And we have to calculate what? This was all given data. We have to calculate surface tension. Surface tension denoted by capital T. T formula for this is rho RH whole upon 2 cos theta. Capital T we have to calculate. Rho value is given, which is 0.6 in 1000, which is here 600 into T is given. Gravity will assume 10 into radius 2 into 10 raised to power minus. Height is given is h. Liquid rise in tube, h is 20 10 raised to the power minus whole upon 2 cos theta, 2 cos 0 degree. T is equals to 60 10 40 10 raised to the power minus 6 by cos 0, which is T is equals to 6000 20 10 raised to the power minus 6. T is equal to 6000 in denominator 10 raised to the power minus 6, 10 cancel out, is equal to 12 by 100. From here T is equal to 0.12. Which of the following option is correct? Option number B is correct. 0.12 Newton per meter is the final answer. Surface tension we have calculated. T is 0.12 Newton per meter. Next question is, if the section factor and hydraulic depth of rectangular channel are respectively different. So section factor is 40 mm and your hydraulic depth is mentioned, which is 4 mm. We have to calculate the top width of the channel. First, what we will do, we will note down the given data. Given is section factor. section factor, which is A rho D is Z is equals to value is given 40. Next, hydraulic depth is given. Hydraulic depth is D is equals to 4 meter. We have to calculate top width. Top width divided by capital T. This thing we have to calculate. As we know, A area of rectangular channel, Z is equal to A rho D, and here Z value is given. Z is what? Section factor value is given 40 meter. A we have to first we will calculate A is your area of rectangular channel. A D is value given 4. D is your hydraulic depth. A is equals to 40 by root. Here 40 by 2. A is 20. Area we have calculated, which is area of rectangular channel is 20 meter. Now we will be calculating top width. For top width, hydraulic depth, is equals to area by top width. Hydraulic depth is given with 4 meter into area is given as 20 by top width. We have to calculate T is 20 by 4 and T 5. So top width 5 meter. Option number B is. So we have discussed important numerical for your TPSC Tripura JE main examination. Subscribe our channel Engineering PTA Education for such lectures. Thanks for watching.